Hello, everyone.
Hello, good morning.
Good morning.
Hi, sir.
Welcome to SimCity 2022. First of all, we would like to thank all others for their contribution. Your certificates will be sent to your email address after the presentation. There are 10 presentations in this session. Each presentation is a maximum 15 minutes. First presentation, dear Guri Viredi.
Turgut Bey, başlamadan bir şey sorabilir miyim ben?
Tabii ki buyurun.
Can you accept Gurvi's request? He is waiting for accepting the request. He wants to join.
Ali Bey'di değil mi az önce?
Gurvi Reddy.
Evet. Ya sunumları Türkçe yapabiliyor muyuz? Normalde katılması planlanan arkadaşım gelemedi. Ben onun yerine devralacağım.
Sunabilirsiniz, problem yok.
Tamamdır, teşekkürler.
Dear Yogesh,
Can you accept? Yeah, can you accept Gurvi Reddy's request? He's
you
waiting
can start.
to join this room. Gurvi Reddy is waiting for your acceptance. He is waiting for your acceptance. He is showing the message that please wait until your request was accepted for this meeting.
Okay.
Can you just check it out?
Can you present?
So that yeah, I will present. Guruvi Reddy is waiting for the request.
Okay,
He wants to join.
No problem. You can present.
Sure. He also has some additional slide for this presentation. Yeah, but I will share my screen meanwhile.
You can share.
Yeah. Let me know once my screen is visible to all.
You can say no problem.
I'm just opening the presentation. This presentation is, I guess, able to see everybody, right? So that I can start.
You can start.
Yeah. So good morning, all. I am Yogesh Rajwade, and along with me, Guruvi Reddy is also work on this paper. So the paper title is Energy Harvesting Using Piezo Transformer from Residual Fault Current 30 milliampere. So I will just give brief background and problem statement. The background is in electrical sector, there is a residual current device. This device is mostly used to safeguard the human if there is a live conductor. So if there is a ground and a live conductor has in some contact, so this device will immediately detect and it will open the contact. So human can have safeguarded. So basically the principle of this RCT on the live conductor, it has a summation transformer which will give you some kind of a signal to the relay and relay will open. We have one additional advanced device we called as a hybrid circuit breaker where this time was very short, as well as it has a capability to measure current and voltage simultaneously, and it has an additional capability of reducing the arc also during the operations. Now the problem statement was in this bypass switch, as you see in the block diagram, it is supplied from the grid, and there is a bistable operation of the contact. Whenever there is a supply, it will change the state and it will in the on state. So to make it in the off state, definitely it needs additional signal to make it off. So when the device was on and there is a grid supply also there, and once grid supply was going down, the state was not changed. And during this time, if there is a ground fault or residual leakage current, then there is no methodology or nothing is available to make sure that this device can be again turned off. So that's the problem statement. I will go to the next slide now. So I'll just briefly describe the what exactly is the hybrid circuit breaker, and then I will explain my proposed solution. So this is the very high level block diagram of my DC or AC hybrid circuit breaker. So as you can see, there is a first block of voltage measurement supplied by live and neutral, and then there is a current measurement. So for voltage measurement and current measurement, these two are needed to make a decision during this operation. And then third block was bypass switch. This is the additional, this is the switch where it will continuously monitor the current and voltage. If arc was there, this bypass switch was get enabled using microcontroller. And then galvanic disconnector. This is the main contact driven by relay driver, and it will give isolation. So this is a brief block diagram of hybrid circuit breaker cell. Now I will jump to proposed solution. So in this block diagram, we are proposing a solution as I explained in the problem statement. If the grid supply was not available during that time, the time was very short. We have only a limited time, mostly less than 300 millisecond or 250 millisecond. So within that time, we have to turn off that main contact. So as you can see, we have an energy harvesting circuit, which will give signal to this bypass switch. And we are proposing, we are getting this signal from the CT, which is 30 milliampere. So with this 30 milliampere, we are with this our existing methodology, we are giving a signal to bypass switch during this 250 or 300 milliseconds, which will safeguard the human from the shock or during the fault. So that's the our proposal. Now I am jump to energy harvesting block diagram. This will give you very clear idea about the green block, which I just shared you about energy harvesting block. That is the elaborated part of this that block. So as you can see, we have 30 milliampere from the CT or current transformer. This 30 milliampere signal we are giving to high frequency oscillator, which is a 50 hertz to 15 kilohertz. This is the range. We can use any range, so that is adjustable. This will give a boost of frequency from 50 hertz to up to 15,000 hertz. So this is required to operate the piezoelectric step-up transformer, considering 150 to 200 conversion ratio, and the size also very compact. And there are several advantages of this piezoelectric transformer. So this will give you conversion of AC to DC, and this we are giving to the capacitor bank, where we are charging this capacitor bank to 48 volt to 20 ampere. So this 48 volt and 20 ampere is needed to power on or actuate that main contact, which I explain you in the hybrid circuit breaker block diagram, and ultimately the load. So this is the sequence of our signal flow. So as you can see, piezoelectric transformer with current boost. There are some additional things, like some of the things we assume that current sensing. Right now we are assuming we have a current transformer, then signal get amplified by the piezo transformer, and using rectifier it get converted into DC, and less than 300 millisecond is the time we have, and within that time we have to discharge the entire current to that contactor coil. So with our calculation, we have only 5 milliseconds available with us to discharge the entire 20 ampere from the load, from the capacitor bank to load. So I will just pass on this to Gurvi, if Gurvi is available. Gurvi, are you in the call?
Yes.
Yeah, you can continue. I will shift to next slide.
Okay. So as Yogesh explained the block diagram and the concept, so now would like to see like how this concept will work, whether it will be able to generate as much of the current and voltages within that stipulated time of 300 milliseconds, and what would be the size of the capacitor, whether it will be able to hold the voltage, minimum voltage, like at least 10% of the plus or minus 48 volts when the 20 amps is drawn from the load, that is the by electromechanical actuator. So and what would be the piezo converter or piezo transformer amplification could be. So so to check all these things, we have used MATLAB Simulink as a platform to simulate the concept. And here you can see like we have taken the current source of 30 milliamps as a input source, and then there is a AC to DC converter and DC to AC converter. Maybe in the practical implementation we can use any oscillator which can able to produce this 50 hertz to 15 kilohertz, but here we have used this dual converter circuit to convert this 50 hertz to 15 kilohertz. So one side we have used a diode bridge to convert to DC, and then MOSFET controlled device to change the frequency. It's a kind of a stepped DC or pulsed DC, and that will be given to the piezo converter. So the piezo converter has been modeled as a equivalent electrical circuit that is suggested by multiple literatures, and we have given the references of those literatures also how to model a piezo converter. Yogesh, can you please go to the next slide? So this piezo converter is modeled as a equivalent resistors, capacitors, and voltage and current sources. And here we have given a amplification ratio of 150. So then after the piezo converter, we have modeled a rectifier to convert this a pulsed DC to a DC, and that will be charging the capacitor. So that has been given to a load of 20 amps, which is going to drop for 5 milliseconds. So that is what the arrangements we have given in the simulation platform. And if you go to the next slide, Yogesh. Yeah, here you can see like we have first graph is the current, the charging current, which is going into the capacitor to charge the capacitor to 48 volts, and from the 30 milliamps has been amplified to around 2 to 3 amps using this piezo actuator, piezo transformer, and that current is used to charge the capacitor for 290 milliseconds. So in 290 milliseconds, the voltage has been built to 48 volts in the capacitor, and that will be shown in the second graph. And the third graph will show you like after 290 milliseconds, as soon as the 48 volts is built in the capacitor, we have applied a load of 20 amps for 5 milliseconds. And there you can see in the second graph, after 290 milliseconds, when the load of 20 amps is connected, so there is a slight drop in the voltage. But that is acceptable. Still, it is dropping from 48 to 45. So still the actuator is able to work with that voltage. So from this simulations, we can see like with proper designing of the piezo and the capacitor sizings, we are able to store the energy of 40 around 48 volts and 20 amps for 5 milliseconds to actuate the bypass switch. So with that, the simulation work is completed, and I will go to the conclusions and the next steps. Yogesh, can you please go to the next slide? Yeah, here you can see, so the concept of energy harvesting has been proposed and simulated using MATLAB platform. We are able to see, we observed like 30 milliamps signal is, we are able to achieve 20 amps for 5 milliseconds. And the next steps is, we need to see how this practically is going to be feasible. We need to prototype this one and check this conversion of the piezo transformer. Is it possible or practically available in the industries? And the second one is we have used some frequency converter where we have used some gate driver. So that needs some external power supply. So we are thinking of leveraging RF energy harvesting to power that gate driver. So that is yet to explore and see how it is going to work. So these are all the next steps we have to take to make it the concept is working or not. That's all I have. If you have any questions, we will take those questions.
Thank you for presentation.
Thank
Is
you.
there any question? Is there any question? Okay, thanks again.
Thank you.
Next presentation, dear Berkay Tahir Ağaoğlu.
I'm here.
Okay, you can start.
Can you see my screen?
Yeah, no problem.
Okay. Hello, everyone. My name is Berkay Tahir Ağaoğlu. I am done this work together with graduate student Enes Başak, assistant professor Halil Bayram, and associate professor Gökhan Sevilgen. I'm double major student on Bursa Anadolu University at Electrical Electronics Engineering Department. So the title of our work is the investigation on the heating performance of the heat pump system with waste heat recovery for the electric vehicle. In the presentation, I will first talk about the air conditioning system in electric vehicles. Then I will explain the waste heat calculations, experimental study and results, respectively. Finally, I will end the presentation with the conclusions part. In electric vehicles, the system that consumes the most energy after the electric motor is the vehicle air conditioning system. Therefore, in our study, we aim to reduce the energy consumption in the air conditioning system. Thus, vehicle range will increase as a result of efficient use of energy. The heat pump systems is widely used in the air conditioning system of electric vehicles. In the most basic explanation in the heat pump, when heat is withdrawn from an environment, that environment is cooled, while another environment is heated with this heat. However, the heat pump system is insufficient to heat the cabin at low water temperatures. That's why PTCs are used. However, the use of PTCs causes high energy consumption and reduced vehicle range. That's why we design a new system to heat the cabin by providing energy efficiency in electric vehicles. This system works with the principle of using heat pump and waste heat together. Now, let's talk about waste heat. Waste heat is a byproduct of the use of energy. In our study, first, the waste heat obtained from the electric vehicle was calculated theoretically. Then the calculated waste heat value will be used in experimental studies. Thus, the results of the new design will be measured. The vehicle characteristics used in the study were chosen similar to the values in the study obtained from the available literature. You can see these parameters in table 1. In our study, it's assumed that the vehicle moves under the ATC driving cycle conditions. In the next step, a driving route suitable for the 4-speed range, distance, and duration of the test route is determined. The elevation profile of the route was created via Googler Pro software, and the average slope value of 1.6% was used in the calculation. The main elements that generate significant waste heat in electric vehicles are the electric motor, inverter, and also battery package. In the study, only the waste heat value obtained from the electric motor was calculated. The waste heat values generated by other vehicle elements are taken from the literature. It's known from the literature that these systems work with 85% efficiency. 15% of the power is released as a waste heat, but only a part of this waste heat can be recovered. The amount of recoverable waste heat for the systems is assumed as 3%. The instantaneous recoverable waste heat amount was determined by calculating this ratio over the instantaneous power. On this page, you can see the formulas used in the calculation of waste heat. The basic theory of vehicle dynamics was used in the calculation. The total traction force of the vehicle is written in equation 1. Equation 1 includes rolling resistance force, aerodynamic drag force, and slope resistance force. The numerical derivative method in equation 2 was used to find the instantaneous acceleration of the vehicle. If we multiply the traction force by the velocity, we get the output power. The ratio between the output power of the engine and the input power gives the engine efficiency. And finally, the instantaneous power of the electric motor can be obtained from equation 5. Now let's examine the graphs obtained as a result of the calculations. Figure 2 shows the speed graph of the vehicle moving with the WLTC driving cycle. And it is seen that the driving takes place in 4 states: low speed, medium speed, high speed, and extra high speed. Figure 3 shows the acceleration time graph of the vehicle. That speed is determined by the numerical derivative method. In the fourth graph, we see the calculated instantaneous power of the electric motor. It can be seen that the instantaneous power of the electric motor varies between negative 17.5 kilowatts and 83 kilowatts. And the average power is calculated about 13.32 kilowatts. The change in the recoverable instantaneous waste heat is as in figure 5. As I mentioned before, instantaneous waste heat is calculated by taking 3% of the instantaneous power of the electric motor. Accordingly, the amount of recoverable waste heat was calculated as 399.58 watts. When the waste heat from other components is considered, the recoverable waste heat is calculated as approximately 2 kilowatts. This recovered waste heat was used as an additional source in the vehicle heat pump system. After calculating the waste heat, the experimental study was carried out in order to examine the effect of the temperature change in the vehicle cabin interior at different ambient temperature conditions. The test room can be shown in figure 6. This figure also shows the developed heat pump system and the vehicle cabin working with the heat pump system. The details of the heat pump schematically presented in figure 7 when the heating mode is on. This system consists of 3 subcycles, and these are coolant and refrigerant cycles. To measure the difference of the designed system, 3 cases were experimentally compared. These cases are the 2 kilowatt capacity PTC, heat pump only, and hybrid system cases. Firstly, the cabin indoor heating demand at 10 degrees Celsius and 15 degrees Celsius ambient temperature values were tried to be met by using only a 2 kilowatt PTC heater. At the end of 20 minutes, it was observed that the cabin indoor temperature values reached the values of approximately 26.1 degrees Celsius and 31.5 degrees Celsius at 10 degrees Celsius and 15 degrees Celsius ambient temperature conditions, respectively. The temperature that provides the comfort condition is 25 degrees in the cabin. For this reason, the three systems will be compared by examining the temperature change in the interior cabin when the outdoor temperature is 10 degrees. In figure 9, for three different systems, the temperature change in the interior cabin while the outdoor temperature is 10 degrees Celsius is shown. At the end of the experiments, the cabin indoor temperature values were measured as 26.1 degrees Celsius, 31 degrees Celsius, and 41 degrees Celsius when PTC heater, heat pump, and hybrid systems are used respectively. The heat pump system consumes less energy than the PTC heater, and higher temperature values were obtained inside the cabin. When the hybrid system was used, it is seen that very high cabin indoor temperature values were obtained at the end of the experiment. However, the cabin was able to achieve indoor thermal comfort conditions almost simultaneously with the heat pump system. And this time is approximately 450 seconds. As a result of the study, the following conclusions were reached. At lower ambient temperatures below 0 degrees Celsius, the single heat pump system can be insufficient. And a hybrid system that includes heat pump, PTC heater, and also waste heat source should be used together to get the target temperature in a desired time period of heating process of electric vehicles. Finally, a significant difference had been observed in the change of interior temperature of the electric vehicle cabin by using the recoverable waste heat as an additional heat source with the developed heat pump system. By using the developed heat pump system, not only energy performance, but also driving range can also be improved in electric vehicles. Thank you for listening.
Thank you for presentation. Is there any question? Okay, thanks again. Next presentation, Dear Ali Güreç.
Sesim geliyor değil mi?
Geliyor, problem yok. Başlayabilirsiniz.
Tamamdır. Öncelikle merhaba herkese. Bana ayrılan süre içinde kısaca yaptığım çalışmadan bahsedeceğim. Çalışmamın ismi Enterconnect'te bir elektrik şebekesinde otomatik enerji üretim kontrolünün adaptif rezerv management üzerine etkisini inceleyeceğiz. Sunum içeriği şöyle, önce bir çalışmanın kapsamından bahsedeceğim. Genel frekans kontrol yönetimi ve AGC sisteminin görevi, adaptif rezerv yöntem ve metodolojisini anlatacağım. Kurduğumuz simülasyon ortamı, senaryo ve simülasyon çıktılarını değerlendirip en son sonuç kısmına değineceğim. Bu çalışma kapsamında adaptif rezerv yönetiminin otomatik üretim performans kontrolü olan etkisini inceleyeceğiz. Bu kapsamda öncelikle bir elektrik şebeke modeli IEEE 9 baralı sistem seçilerek kurgulanmıştır. Otomatik üretim kontrol algoritması Python ortamında geliştirilmiş ve kurulan bu IEEE 9 bara şebeke modeli Disk Silent Power Factory tool'u kullanılarak RMS simülasyonları gerçekleştirildi. Adaptif rezerv yöntem metodolojisi ise piyasa odaklı ve güvenlik odaklı frekans kontrol yaklaşımı ele alınarak ortaya konulmuştur. Slaytın ilerleyen bölümlerinde değineceğiz zaten. Genel frekans kontrol yöntemi ve otomatik üretim kontrol sisteminin görevinden bahsedeyim. Bilindiği üzere elektrik enerjisi depolanamıyor yüksek miktarlarda ve üretildikten sonra tüketilmek zorunda ve bu dengede durmak zorunda. Bu yüzden şebeke frekansı elektrik üretim ve tüketim dengesine bağımlıdır. Üretim ve tüketim dengesinin bozulduğu her koşul bizim frekansımızın nominal değerinden saptırarak bir frekans deviyasyonuna sebep olur. Gerek şebeke frekansı güvenli sınır içinde tutmak, gerekse taahhüt edilen ticari elektrik transferi kontrol etmek için frekans kontrol sistemi kullanılır. Bilindiği üzere Türkiye'de 2010 yılında Avrupa ile enterkonnekte bir şekilde Yunanistan ve Bulgaristan hattına bağlanmıştır. Bu kapsamda da taahhüt ettiğimiz bir ticari elektrik transferimiz var. Bu değerleri sabit tutmak zorundayız. Otomatik üretim kontrolü frekansı düzenlemek, nominal değerine getirmekle beraber taahhüt edilen ticari elektrik frekans değerinde iletim hatları için sabit tutmaya yarar. Bu anlattıklarım için alınan aksiyonların tümüne de frekans kontrol işlemi denilir. Şebeke frekansı temel olarak 4 aşamalı bir kontrol yapısıdır. Primer kontrol dediğimiz herhangi bir şebekede nominal frekansı bozulacak bir üretim kaybı veya ekstra bir yük alınması sonucu öncelikle primer kontrol devreye girer. Bu da santrallerin bozulan üretim tüketim dengesini yeniden sağlamak için lokal olarak kendi governorlarla, kontrolcülerle yaptığı tepkidir. Grafikte göreceğiniz üzere T0 anında meydana gelen herhangi bir eventte şebekenin inerşiyasına bağlı olarak bir dump gerçekleşir. Bu dump gerçekleşme bitim noktası aslında şebekede bulunan jeneratörlerin primer kontrolcülerin devreye girerek lokalde aktif güç üretmeleriyle son bulur. Ve bu tipik olarak 5 ila 10 saniye içerisinde gerçekleşir. Bu olaydan sonra şebeke nominal değerine gelmez ama daha fazla da düşmez. Çünkü primer kontrol bir steady state değerinde frekansı tutar ama nominal değerine ulaşamaz. Burada sekonder kontrol devreye girer. Yani bizim AGC dediğimiz Automatic Generation Kontrol yapısı. Bu kaybolan üretim tüketim dengesini kontrollü bir şekilde yeniden şebeke frekansını nominal 50 Hz'e getirmek için kurulmuş bir algoritmik yapıdır. Genelde merkezi bir yerden yönetilir ve tüm jeneratörlere üretmeleri gereken aktif güç sinyal değerlerini göndererek şebeke frekansını nominal düzeye getirir. Diyelim ki sekonder frekans da bunun için yetmedi. Şebekemizi kurtarmak için tersiyer kontrol devreye girer ve bu durumda biz şebekeden yük atmaya başlarız veya ekstradan sekonder rezerv ve katkı olacak tersiyer rezervlerimizi devreye alırız ya da dediğimiz gibi yük atarız. Ve tüm bu olanları elektrik frekansıyla elektriksel frekansla normal zaman arasında geçecek farkı kontrol almak için de bir time kontrol algoritması kullanırız. Tezim özelinde yaptığım adaptif rezerv yönetimi yenilikçi husus şu: piyasa odaklı yaklaşım, frekanstan meydana gelen herhangi bir sapma sonucu oluşan alan kontrol hatası değerini sıfıra indirmek için normalde TSO'lar en ucuz rezerv grubuna ait santrallerden başlayarak en pahalı rezerv grubuna ait santrallere doğru aktif güç artırım ve azalım sinyali gönderirler. Genel olarak AGC yapıları bu şekilde çalışır. Tezimde farklı nokta ise güvenlik odaklı bir yaklaşım metodolojisi geliştirerek frekanstan meydana gelen herhangi bir sapma sonucunda santrallerin sekonder rezerv için ayırdıkları fiyatlara bakmaksızın tüm üretim santrallerinin alan kontrol hatası değerini sıfıra indirmek için aynı anda aktive edildiği stratejidir. Çalışma kapsamında öncelikle load frekansı kontrol, reserve management kontrol ve power allocation dediğimiz Python ortamında initialize ettiğimiz algoritmalarımız var. Bu algoritmalar için gerekli bir takım Dixilent tarafında şebeke modeli üzerinden aldığımız bir takım datalarla önce bir ACE hesabı yapılıyor. ACE hesabı da sapan frekans artı şebekenin inerşiyası çarpımı ile bulunuyor. Bulunan bu ACE eğer bir alarm condition'ını geçiyorsa sistem acil durum olarak secure driven dediğimiz güvenlik odaklı yaklaşımla frekansın nominal değerine getirmeye çalışıyor. Böyle bir alarm condition'ı geçilmediyse normal piyasa odaklı dediğimiz market oriented control approach'la üretmesi gereken aktif güçleri santral arasında dağıtıyor. Simülasyon ortamı bahsettiğim gibi bir interconnecte şebekede external bir grid var. Bunun haricinde 3 jeneratörden oluşan 9 baralı bir sistemimiz var ve ilgili baslara bağlı 4 sınıf yükümüz var. 10 megawatt ile 40 megawatt arasında değişen. Santrallerimiz de genel olarak genel uygulamaya esas bir hidroelektrik santralimiz, bir kombine doğalgaz çevrim santralimiz, bir de termal santral var. Bu 3 santralin tabii ki de fiyatlamaları ve devreye girmelerine göre rezerv gruplarına öncelikleri atadık. 1 numara, 2 ve 3 numara olarak. Santrallerin nominal güçleri hidropower plant için 120 megawatt, combine çevrim santral için 80 megawatt ve termal santralimiz için de 50 megawatt olarak belirledik. Primer ve sekonder rezervleri 3 jeneratör grubu için de eşit belirledik. Hidro için 24 megawatt, combine gaz çevrimi için 16 megawatt ve gaz türbini için 10 megawatt olacak şekilde. Sağ tarafta gördüğünüz ise soldaki enterkonnekte şebekenin Disk Silent ortamında simüle edilmiş hali. Bir takım RMS simulation ve real time datalar buradan. OPC Matricon server aracıyla Python ortamımızda çalışan otomatik üretim kontrol algoritmaları akmaktadır. Ve buradan gelen real time data transmission'la ilgili alan kontrol hatası hesaplanarak rezerv kapasiteleri doğrultusunda santrallere üretilmeleri gereken aktif güç oranları gönderilmektedir. Senaryo ve simülasyon çıktıları. Senaryomuzda öncelikle senaryo case 1'de ACE alarm limitini aldığımız yükten çok fazla bir seviye olan 100 megawatt'a da tutarak alarm condition'ı oluşmasını engelleyip piyasa odaklı yaklaşımda sistemde meydana gelebilecek bir hatada jeneratörlerin tepkileri ve frekansın nominal seviyeye gelme süresi soldaki grafikte görülmektedir. Burada T0 anında 50 megawattlık bir yük alınıp market odaklı yaklaşımla jeneratörleri sırasıyla devreye sokarak önce gördüğünüz gibi en ucuz olan hidroelektrik santralimiz kırmızı hat ilgili yükü üretime başlayarak alınan yüke karşılık enerjiyi sabit tutmaya çalışıyor frekansla beraber. İlgili santral doyuma ulaşınca ikinci seviye santralimiz olan combine doğalgaz çevrim santrali devreye giriyor ve bu yük almaya başlıyor. ACE hala sıfıra inmediyse ve hala alan kontrol hatamız varsa ve frekans nominal değeri oturmadıysa üçüncü santralimiz devreye girerek ACE hatasını sıfırlayana kadar üretmeye devam ediyorlar. Bu sürede gördüğünüz gibi bir güvenlik odaklı yaklaşım olmadığı için ACE'in oluşmasıyla beraber, frekans sapmasıyla beraber tekrar nominal seviyeye gelmesi yaklaşık 85 saniyelik bir süreci kapsıyor. İkinci durumda alarm limitimizi aşacağımız bir seviye olan 1 megawatt'a çekip yine 50 megawattlık bir yük aldığımızda ve T0 anında şebekeye aldığımız 50 megawatt yükle frekanstan meydana gelen bozulma ve alan kontrol hatamız yine burada yükseldi. Bu sefer sağdaki grafikte görüyoruz ki santraller sırayla değil, hepsi hep birlikte devreye girerek mümkün olan en kısa süre içerisinde ACE değerini sıfıra çekmeye çalışıyorlar. Ve üçü de aynı anda yük aldıkları için gördüğünüz gibi burada ACE'imizin sıfıra gelmesi ve frekansın nominal değeri oturma süresi bir önceki market odaklı yaklaşıma göre 45 saniye gibi neredeyse 2 katı daha karlı bir süreyle ACE değerimiz sıfırlanıyor. Senaryo 3'te farklı olan şey şu. Bu sefer santrallerimizin yük alma ve yük atma hızlarını birbirinden farklı hale getiriyoruz. Yine 50 megawattlık bir yük aldığımızda piyasa odaklı koşulda kalmak üzere alarm limitimizi 100 megawatt'a çıkartıyoruz. Farklı yük alma ve yük atma range'lerinde jeneratörlerin verdikleri tepkiler sağ tarafta göreceksiniz. Hidroelektrik santralimiz 50 megawatt bölü dakikada yük aldığı için daha dik bir şekilde ve ACE'i daha hızlı elimine edecek bir şekilde yük almaya başlıyor. Buna nazaran combine doğalgaz çevrim santralimiz daha soft, daha küçük step basamaklarla üzerine yük alıyor. Ve en son doğalgaz çevrim santralimiz hala alan kontrol hatası elimine edilmediği için ve bir önceki iki jeneratörün rezerv kapasiteleri de olduğu için 10 megawatt bölü dakika ile çok soft ve slow bir eğimde yükünü alarak ACE'i sıfırlıyor. Farklı yük alma ve yük atma range'leri için bu sefer güvenlik odaklı yaklaşımla alarm limitini 1 megawatt'a çekip 50 megawatt yük aldığımızda santraller bu sefer birbirinden farklı ama aynı anda devreye girerek ACE elimine etme hızları önceki grafiklere göre 40 saniyeye kadar azalarak aslında en hızlı ve optimum tepkiyi vererek piyasanın ve frekansın nominal değere gelerek stabil bir şekilde elektrik şebekesinin tekrar kontrol altına alıyor. Sonuç olarak AGC kapsamında kontrol edilen üretim santralleri market odaklı ve güvenlik odaklı adaptif rezerv yönetim stratejisi kullanarak karşılaştırmışlardır. Market odaklı rezerv yönetim stratejisinde üniteler fiyat odaklı ve sıralı bir şekilde kontrol döngüsüne bahsettiğimiz gibi dahil olurken güvenlik odaklı rezerv yönetiminde tüm üniteler aynı anda ve alan kontrol hatasını en hızlı şekilde elimine edecek bir şekilde tepki verip stabil ve kararlı bir hale getirmek istiyorlar şebekemizi. Bu çalışma kapsamında adaptif rezerv yönetim metodu ile AGC performansının iyileştirilerek daha hızlı ve kararlı bir yük frekans kontrol döngüsü sağladığını gösterilmiştir. Anlatacaklarım bu kadar. Teşekkür ederim. Sorular varsa alabilirim.
Sunum için teşekkürler. Soru yok sanırım. Bir sonraki sunumdan devam edelim. Next presentation, diğeri Buse Taşdemir. Taşdemir. You can start. Sorry. Buse Hanım, duyabiliyor musunuz bizi? Şu an sesiniz anlaşılmıyor bizim tarafımızda. Bağlantıyla alakalı problem var sanırım. Yok, yine bozuk geliyor. Sesteki problem düzelmedi ama başka bir bağlantı deneyin isterseniz. Biz bir sonraki sunuma devam edelim. Ondan sonra siz alalım. Dear next presentation, dear Al-Falahi. Okay. Dear Nisar. Dear Nisar Ahmet.
Hello.
Hello.
Yeah, I'm Nisar.
Okay. You can start.
Yeah, okay. Uh, Hello, good day, all of you. My name is Nisar Ahmad, and I'm presenting. The topic of my presentation is brain tumor detection using convolution neural network. So the outline of my research is presentation is introduction and after data processing, methodology, transfer learning approach, methodology, and conclusion recommendation. So the first is come to the introduction. So medical image techniques are used to image the inner portion of a human body for the medical diagnosis. So, and medical image classification is one of the most challenging and fluent topic in the field of image processing. Medical image classification problem, tumor detection or detection of cancer is the most prominent one. And recent time, the physician are following advanced method to identify tumor, which is more painful for patients. So MRI-based medical image analysis for a brain tumor study has been gaining attention in a recent time due to an increased need for efficient and objectives evolution of a large amount of medical data. Analysis of this diverse range of image types requires sophisticated computerized quantification and visualization tool. So automatic brain tumor detection from MRI image will play a fundamental role in this case by elevating the need for manual processing of a huge amount of data. So what we have what is a brain tumor? A brain tumor arises an abnormal cell grow inside the brain, and it has a high effect because it is a special item of the main nerves motor of a person where each small defect can cause a lot. For this reason, it is important to find a way of early detect of a brain tumor. This importance comes from the fact that early detection dramatically increase the possibility of treating the disease and saving patients' life. Recently, cancer treatment have evaluated considerably, especially in the early stage of infection. The chance of survival are very high for those patients who receive early treatment compared to those who don't have this opportunity in the early stage of the disease. So we have to classify brain tumor. They have like two main types of a tumor is benign tumor and malignant tumor. The benign tumor is the early stage. They're like a non-cancers and it's grows slowly and it's like a clear border and it's easy to identify. But malignant tumor is a cancer, it's grow rapidly and this dotted border. So it's typically is hard to be finding. So this is the image for benign and malignant tumor. So we have the objective, we provide the platform for the physician who find the early stage, the brain tumor and the diagnosis and it's a we use for that the deep learning techniques to detect the brain tumor. So they have like the statistic it show like horizontally show the survival and vertically show the age for the blue bar is show for a man and the pink one for the woman. They have like the different ages have the different ratio. They have like problem how like detect the tumor. We implement the problem using convolution neural network based detection and brain tumor MRI image processing techniques and data analysis. So train a model using the data set to help the physician in making diagnosis of a brain tumor MRI. Computerized application can be used deep learning techniques to increase accuracy and efficiency in a diagnosis. So I use for this is a Kaggle data set. They contain like a two folder, yes and no, and it has 253 brain MRI images. The yes folders contain 155 brain images which have like a tumor, and no folder contain 98 brain MRI images, and it's have like the early stage of a tumor, benign, like is non-tumorous. So it's calculated 61% of images is like a positive, is contained in a yes folder, and 39% of images is in a no folder. So for after that, when we get the data, then we prepare that data for the next process. So we apply data augmentation. Data augmentation is a strategy that increase our data. Is actually the data is not that much for the training. So when applied data augmentation techniques is cropping, padding, horizontally flipping is and is used for train the large neural network. About this data, the data set is go like two folder, yes and no. So after the augmentation, applied augmentation, the actual sample is come 2065. Then I use like 1960 training example, 52 for the validation, and 52 for the test. Is shown in the images. This is the data splitting according like used for the 15% for validation, 15% for the testing, and the remaining 70% is used for the training. After that, cropping the image. Cropping image is to act like a photo or image, removing unnecessary parts, showing like in the figure. And the after that, resize the image because it's used some pre-trained model is used. The height and width is 240 with 3 channel, and it help like zooming in the images. Many times resize image, it like shrink it or scale it up to meet the size requirement. So OpenCV provide us with a several interpolation method for resizing an image. Normalization. After come normalization to scale the pixel value to 0 and 1. Normalization is a database design techniques often apply is a part of data preparation for a machine learning. The goal normalization is to change the value of numeric column in the data set to common scale to reduce redundancy with distorting difference in the range of values. After come the methodology section, we have like a proposed workflow. First, and data set, we get the data set. After apply augmentation, is different techniques: cropping, resizing, normalization, visualize the data, and the next step has come like the CNN model. The CNN model is to create 12 convolution layer or built from a scratch in addition to fully linked hidden layer, and output layer softmax activation is utilized since the probability for each class must be output. And ADAM optimization is used to maximize the network. The model is applied to train set of where its size is a part of the training method. The network weight will be changed automatically depending on the gradient determined for each batch. Epoch are defined as one iteration across the whole training set. Individual is typically trained until has experienced a consistent loss after training and verification. The model. So the result got 97% training accuracy and 94.28% validation accuracy. They have like a layer of CNN model is to define the input, convolution, ReLU, zero padding, max polling. So is applying according to this definition. This is the CNN model architecture summary. It's come like the training, the model is 24 epochs, and those are the loss and accuracy plots. Loss occur during the training and validation is the left side, and the right side is accuracy training. I got the result from this is around 94 to 95%. Is the predicted image from CNN model is the confusion matrix. So the confusion matrix for the test accuracy give 90, and for the validation accuracy is 94%. And below from the actual and predicted image from the CNN model. After that is transfer learning approach. Transfer learning approach is the deep learning model based on transfer learning demands huge volume of data for training and executing optimally. Is a high resource and sufficient time to train the model. Transfer learning find a solution to another task by utilizing knowledge gained from previously learned tasks. It is an approach of utilize pre-trained CNN model based on parameter fine-tuning for computing identical tasks. This approach is used when the dataset size is small for training and extensively adopted for a computer vision-based problem. So transfer learning generally work on acquiring the ImageNet dataset as an input. The convolution layer freeze and wait with a particular dataset are transferred to other CNN model and then generate the final image classification as an output. Therefore, in a nutshell, it is called an improved learning model for a new task by transforming knowledge gained from existing tasks. So I use the VG16, Inception V3, and ResNet 50, these three trend model. So the VG16 CNN model, and this experimentation apply the VGG16 pre-trained CNN model. Because of small image data set and to avoid overfitting problem, the model is fine-tuned by freezing some of the convolution layer. And VGG16 is a CNN model with 16 convolution layer developed in 2014 by a researcher. The model concept brain MRI images is an input with a dimension 224 cross 3. It incorporates a convolution layer with a kernel filter of fixed 3 cross 3 filter size and 5 max polling layer and dimension 2 cross 2 in a size within the network. It also includes extensively relay activation function and 2 fully connected layers with a soft max output layer. Is a broad network that contains approximately 138 million hyperparameter stack multiple convolution layers to construct deep neural network that improve the ability to learn invisible handcrafted feature. So the hyperparameter to tune are the neuron and epoch count, softmax activation function, learning rate, and optimizer. The number of convolution layer is the second step of the hyperparameter to undergo tuning. This is the image for the VGG16 model. And this is the summary of the architecture. It's like to use the flatten and dense, and the total param is using the 14.73.9777, trainable param 25.089, non-trainable param is 14.7.14.688. This is the training the model, the VGC training and validation loss curve, and the right side is the validation accuracy curve. This is the confusion matrix, and it's got like the result is 98% for the accuracy, and for the test is give 100%. Inception V3 CNN model is like developed by the Google, and it have 5 million parameter with the 22 layer, and its dimension 1 cross 1 or 3 cross 3 or 5 cross 5 to capture handcrafted feature at different scale, including the max polling layer. The reason to use filter with 1 cross 1 kernel is to reserve computation time with less impact on network performance. Then later, Google extended up the Inception network to Incept v3, in which convolution layers are rescaled to decrease with a hyperparameter. Inception v3 is a 48-layer deep neural network which classify MRI brain image and 2000 image classes and also avoid overfitting problems. This is the architecture of Inception v3 model. This is the result for the training and for the testing. Predicted image from this give the validation accuracy for the confusion matrix is 44%, and for the test accuracy is 48%. The last model I use with CNN model is ResNet 50. Is 50-layer residual network with 26 million parameters introduced by Keming, Microsoft researcher in 2015 for image recognition and classification. And residual network, the term residual is feature subtraction. The network also overcome degrading image classification accuracy problem. It includes skipping connection in addition to enormous batch normalization. These skip connectivities are specified as gated recurrent units are gated unit. This model network establish a direct connection between n layer input to some n plus x layer, which propagate additional layers to be stacked in order to construct a deep neural network. The residual network has a lower time complexity when compared with the other model. This is the architect of the ResNet model, and this is the result for the training and for the testing. This is the confusion matrix and the predicted model. Give accuracy 48 for validation, 48% for validation, and 60 for the test accuracy. This is the result and training accuracy for the VGG16 is 99.94% is the best one. After second number is the CNN model, and further the other two model. The conclusion is a result of training our custom model using 2065 image for a total of 22 epochs and 32 batches. So got the above result. So this research method determine whether image of brain tumor or MRI or not. This was accomplished using the CNN model VGG16, Inception v3, ResNet 50, and other architecture. After just 22 epoch of training, this model could correctly predict MRI brain tumor image with a balanced accuracy of nearly 99% on the validation and test set. So further work on 3D images, build our one data set and try to detect the grade and stage of the tumor and try to predict the location of the tumor from a 3D images. Yeah, thank you.
Thank you for presentation.
You're welcome.
Next presentation.
Turgut Bey, şu an sesimi alabiliyor musunuz?
Aha, geliyor, problem yok. Hazırsanız başlayabilirsiniz.
Olabilir, tamamdır. Ekranımı paylaşayım.
Tamam.
Hi, I am Buse Daşdemir. I'm a design engineer at Essentra Components. I work in the R&D department. The subject of our presentation is the effect of engraving depth and silicon geometry on PET printing efficiency. First of all, I will explain what PET printing is, what cliché and silicon are, then I will explain our case study. Printing techniques requested color, shape, logo, and so on. Its name given to the whole of the method used to print materials on any object. PET printing is a printing technique made by using a cliché, printing pad, other name silicone, and printing ink. The piece called cliché is a sheet metal material. The pattern desired to be printed on the cliché is processed by carving or embossing on the metal sheet plate, thanks to necessary equipment. After the paint in the paint resolver on the cliché is transferred onto the cliché, the print pad transfers the pattern onto the product. Efficiency in PET printing can vary with the amount of the print and cycle time. For example, if the printing on piece is 1 cycle instead of 4 cycles, it will shorten its time, increase the amount of the production, and increase the efficiency of the process. There are two main factors affecting this efficiency. First factor, cliché engraving depth. Second factor, print pad geometry. What is printing pads? Pad printing. It's a pad printing element that transfers the desired pattern to the surface to be printed by absorbing in the ink the cavity on the cliché. One of the factor affecting the quality of the pattern on the product is this printing element. As seen in the picture, silicones are separated according to their geometry shape. This fishbone silicone, rectangular geometry silicone, and round geometry silicone. In order to have an efficiency production in pad printing, round or conical silicones should be selected. It should be noted that it's wide angle. And the pattern should be 20% to 40% larger than the size of the transfer product. What is cliché? The cliché is pad printing element that has an inward chamber and contains ink in its chamber. Cliché are produced from emulsion-coated steel material spatial. In order to have an efficient production in PET cliché, the engraving depth of the plate changes the amount of ink and causes a change in the quality of the print. The engraving depth, mostly thin steel plates, varies between 20 to 40 micron. Unnecessarily, deep cavities might cause the ink dispersed on the product to be printed, while poor quality printing results in the cases where the cliché engraving depths are low. Case study. In this study, we examined the efficiency of PET printing on the product we produced in the own factory. 3 different silicone and 3 different cliché types were used. Cliché used 28 to 30 micron, 30 to 32 micron, and 36 to 38 micron cliché. The silicone used fishbone silicone, rectangular geometry silicone, round geometry silicone. We try to achieve the best printing by using 3 parameters that affect the pattern visible on the screen and PET printing efficiency. We did 3 different experiments. First of all, 28 30 micron degree cliché was used. PET printing was done with 3 different silicones by keeping the cliché depth constant. In this experiment, it was observed that the pattern was not transferred in the first printing between the 3 silicone types. The second and third edition were made. The pattern has been transferred to the product as much as desired. In the fourth printing, the desired pattern is completely transferred to the product. Second experiment, 30 to 32 micron degree cliche was used. Pad printing was done with 3 different silicons by keeping the cliche depth constant. In this experiment, the same result was observed as in the first experiment. In the last experiment, third experiment, 36 to 38 micron degree cliche was used. Pad printing was done with 3 different silicons by keeping the cliche depth constant. In the last experiment, the desired pattern was transferred to the product surface in the first printing of rectangular silicon, while the fish belly silicon and round silicon were able to print efficiently in the 3 cycles compared to other silicons. Finally, as seen in the tables, we achieved 100% efficient printing by using rectangular silicon and 36 to 38 micron cliche. Thank you for listening to me.
Hi, Doctor.
Hi.
Thank you for presentation. Is there any question? Okay, thanks again. Next presentation, Dear Ahmet Fatih Tabak.
Evet hocam.
Sunumunuz alırsa başlayabiliriz.
Tabii ki sadece
Diğer sunum paylaşımı sonlandırdık. Tamam, şimdi paylaşabiliriz.
evet. Okey. Ekranımı görebiliyor musunuz?
Görünüyor, problem yok.
Tamam. Sesim temiz geliyor mu?
Geliyor.
Okay. Teşekkür ederim hocam. Welcome to my simulation. Today I will talk you, I'm sorry, welcome to my presentation. Today I will talk you about simulated motion control of a school of microrobots with random walks. This is a numerical study on multiple, multi-scale, multiple robots. So the outline and the contents, I will talk about the general motivation, then I will talk about previous studies, the problem definition, numerical approach to the problem. I will briefly talk about what I did for the numerical studies so far. I will talk about the latest study. I will introduce the hydrodynamic interactions, the random walks for the bacteria. I will focus on the numerical analyses, give you early results, and I will present the new problem definition. So the motivation is to use microrobots in live human tissue. The idea is to employ microrobots for different diagnosis and therapeutic applications in either bloodstream or any other tissue in human body, because the human body is full of liquids and channels. So it's like a sponge. So it is possible to move inside. Now, when I was doing my postdoc studies in Max Planck, I was involved in some of the studies with microrobots. To the right, what you see is a modified E. coli cell. And it was modified with magnetic particles so that we were able to control its swimming by using an external magnetic field. And to the left, what you see is we were able to track the position of single artificial magnetic robots using ultrasound waves. So it's basically possible to employ real bacteria and to track individual robots. Now, the problem is, if you look at the literature, you will see that researchers are trying to achieve preclinical and clinical tests. Of course, it is quite early for clinical tests, but researchers are trying to achieve successful preclinical tests with micro robots. For instance, here you see figures from a paper published in Science Robotics in 2020, and the researchers, the authors, used rabbit synovial joint to demonstrate the usefulness of microrobots for generating the cartilage of the joint. Now, the thing is, even without any fluid flow present, the robots tend to disperse in the volume. So when we try to visualize them, what you see here is from another study from the literature. The authors visualized a microrobotic swarm in a fluidic medium. And the picture they got here is a cloud, basically. It is not always possible to visualize individual microrobotic agents, but it is possible that they will, basically it is possible that they will go in different directions, even if under control, they can deviate from the gate that is planned for the center of mass of the group. So my numerical approach to the problem is I have a equation of motion for the bacterium using the principle of low Reynolds number, assuming that the rigid body accelerations are omissible. So we can simply say that the acceleration, rigid body acceleration, is equal to 0. And then I will show you the schematic for the drawing for the simulated setup. But then there is a magnetic field emanating from a permanent magnet, which is modeled. There is a robotic arm carrying that magnet, again modeled in the simplest possible way. And there's an adaptive motion control dealing with the heading control of the bacteria, actually multiple, and the robotic arm. So this is the robotic arm. So this is what did I simulate so far. There is a 3 degrees of freedom robotic arm, which is which has the simplest inverse kinematics. It's a prismatic revolute joint. So each axis corresponds to one axis in the lab frame. And the end effector of the robotic arm carries a neodymium magnet, a powerful magnet, simulated, of course, again. And the magnetic field, the changes in the magnetic field are is supposed to control the heading of the bacterium cell. The bacterium cell is subject to the magnetic field, and also it can come into contact with any boundary should it exist. So I tried different, so far I tried different geometries for the bacterium, a bacterium with helical body, a bacterium with 2 tails, with the same robotic arm. I even tried simulated a magnetotactic bacterium, a single cell in synovial joint of a human, and it was published in Journal of Biomicrorobotics. And lately I am working with swarms. Actually, when I say swarm, it is computationally exhaustive to simulate multiple bacteria because of the reasons I will explain. And the first thing I did was to try to simulate their motion on plane when they are confined to a plane, meaning that they can move back and forth on a plane, but could not move in the 3rd dimension. So there's a bilateral control approach here. The robotic arm is supposed to track the bacterium cell or the center of mass of the bacteria, while the bacteria is supposed to align itself with the magnetic field of the permanent magnet. So each robot, in a sense, control one another. So with single bacterium cell, of course, I simulated the step response for heading. I used continuous control signal to characterize the performance of the system. I used discrete control signal again to figure out how the system would behave. And it has a very slow response because the cell is moving in, I mean, under low Reynolds flow conditions. Even, I mean, Newtonian or non-Newtonian doesn't really matter. The system is quite damped, so the response is quite slow. The latest study is this way. I mean, you can see the figure here. So there is a synovial joint of a human being, adult human being. I got the information geometry from the literature. It is a non-Newtonian medium, so it has non-Newtonian characteristics of the synovial fluid. And there are multiple, there are only 3 bacteria here with two-way hydrodynamic coupling, meaning that they are affecting each other when while they swim. I introduced the random walks, the Brownian motion, basically because of the temperature of the environment and sudden little jumps in spatial coordinates. And the bacteria are allowed to exhibit 6 degrees of motion this time. So they are not confined to any plane. They can move in any direction, and there is a outcome of that, basically. So this is the Simulink schematic for the numerical study. This basically showcases the how the information within the simulation is shared and distributed. So the hydrodynamic interactions, I searched in the literature and I found only few equations, to be honest. So one of them is by Ishikawa et al. A study from 2007. It is basically a very simple, a simplified, I should say, simplified equation representing the interaction, hydrodynamic interaction between 2 bacteria cells. So I applied this on 3 bacteria cells here. So they are all affecting one another simultaneously as they move around. The random walks is something, it's a tricky concept because when we try to simulate such a system, we want it to be a deterministic model. But if you introduce the thermal energy and the random walks in terms of force and torque in the equation, it becomes stochastic differential equation system. So it is an entirely different concept. It must be solved different than ordinary, how we solve ordinary differential equations. So I preferred to superimpose the random walks at each time step after the ordinary differential equations are solved. It is a little bit costly, but the differential equations remain deterministic. So it is based on thermal energy. There's a distribution function and the fluid track of the non-Newtonian environment for this study. So the focus of the numerical analysis is how feasible is to, is it simulate, to simulate the multiple bacteria, and how feasible is to control the center of mass of a bacterial group. These are the early results. So there are successful and unsuccessful simulations. This is one of the successful simulations. So basically, you can see the result, the rigid body motion for translation and for rotation separately to the left and to the right. And basically, in this successful simulation, it's only, what is what is different? The difference is the initial conditions. So basically in this simulation, you can see that the bacteria are moving almost in unison. They have almost the same heading, and they are moving as a group, you can say, as a one unit. But in this case, this is one of the unsuccessful simulations. I would like to say, in this particular case, I saw that although the center of mass of this, so the controller is controlling the center of mass of the bacterial group. That's the problem, basically. Although the center of mass of the bacterial group is, it seems to do something, but individual bacterial cells, they are basically, they are having different headings. They are moving in different directions. And these are the simulations for only 1 second for a magnetotactic bacteria. And if I continue with the simulation, I see that the controller actually could not simply achieve controlling their motion, but it tends to control the center of mass, but it simply loses one of the bacterium cells. So the reason is the contact force. Basically, when the bacterium comes into contact with the boundaries of the synovial joint, it tends to do something else because of the hydrodynamic interaction between and of course the tactile contact between the bacterium and the solid boundary. So basically it just wanders off in a sense. So we have a new problem definition for the next study from theoretical and numerical point of view. So the controlling the center of masses is misleading, especially if the group is small in numbers. Even if large in numbers, then again, there will be a lot of, the sizable portion of the bacteria will be lost in over time. So even if there is a flow in the medium, then it will be even worse. So the question is, what should be the sensing and control approach for a large group? Because it is computationally exhaustive. And remember, this is from a theoretical and numerical point of view, not experimental. And probably artificial intelligence could be summoned to track the individual bacterium cells randomly at a sporadic intervals. We don't want to lose the artificial or cybernetic, doesn't matter. We don't want to lose our micro robots because they can end up in undesirable locations, creating some unforeseen medical conditions. So it is quite important to strictly control their position. Okay, thank you very much for listening. If you have any questions, I can answer.
Okay, thank you for presentation. Is there any question? Next presentation, dear Furkan Nur Deniz.
Okay, can you hear me?
Yeah, you can start.
Okay, can share my screen. Can you see my screen?
Yeah.
Okay. Hello, I am Furkan Nur Deniz from İnönü University. In this presentation, to preserve the fractional order PID controllers optimality in practice. Firstly, I'm going to talk about proposed approach after giving a short introduction and definition of the problem. Then I'm going to talk about the simulation results, and you know, fraction control systems and controllers are very popular in recent years, but there are some problems in practice. In this study, I propose a solution to the practical application problem. A fraction order PID controller, which compared to the traditional PID controller has certain advantages such as flexibility and effectiveness. It has been revealed in many studies that tuning of 5 parameters of FOPIT controller to a control system gives more effective results. In a recent study, it was reported that it has an advantage of energy efficiency by reducing the control effort. FOPIT controller design techniques are since frequency response of a fraction order integral and a derivative operators can be expressed exactly, and fraction order PID controller design techniques which use frequency domain specification have been frequently proposed in frequency domain. However, such ideal FOPIT designs which have theoretically optimal values cannot be implemented in real-world applications. They can be implemented by using approximation methods in the practice. Problem and motivation of this study. Fraction order derivatives have unlimited memory characteristics because they depend on non-local conditions, and they need to use approximation methods, integer order approximation methods to be implemented. And accordingly, a preservation of optimal values for a fraction order PID controller design can be a problem in the real-world implementation. Ideal FOPIT controller designs cannot be implemented in the real-world applications. In other words, the optimality of the ideal FOPIT may not be preserved during real-world implementations because of approximation methods. The main motivation of this study is to show that ideal fraction order PID controllers may not meet the design specifications, and optimality when they are realized by using approximation methods in real-world control application. This problem can be overcome by incorporating approximation methods in the design process. A solution proposal to the problem. I have a question in this slide, and we can consider to overcome the problem with this proposed approach. If we still have to use an approximation method in realization, then wouldn't it be better to add these approximation methods to the controller design process? Incorporating the approximation method into the design process can overcome this problem so that optimal design parameters can be preserved in the controller implementation, in the practice, in the real-world implementations. In this study, first, to illustrate necessity of incorporation of the approximation method in the design process, the approximation method was not included in the FOPIT design procedure. Then the continued fraction expansion approximation method was included in the design process, and it was demonstrated the frequency responses that the optimally designed FOPIT controllers could satisfy the design specifications and preserve design optimality of the control system when they were implemented. A fraction order PID, you can see from this equation. Pardon. Fraction order PID controller has the coefficients, you know, Kp and Ke and Kd represent the proportional, integral, and derivative coefficients, and lambda and mu are fraction orders. If you write lambda and mu are 1 in this equation, you can obtain the traditional PID controllers. Implementation, sorry, pardon. Implementation of these controllers in the practice, you need to use an approximation method because a fractional derivative has a long memory properties inherently, and we can see from this equation an integer approximate of a fractional derivative can be expressed as this equation. Alpha is range of 0 and 1. In this study, in the literature, several approximation methods was reported for fractional order implementations. But in this study, continued fraction expansion was preferred because it's dependent on continued fraction expansion of derivative function. And the fourth order integer approximate transfer function was preferred in this study. This approach can use with another approximation methods such as Ostalot, Matsuda, and other methods in the literature, because the concept is acceptable for all of these approximations. Approximate fraction order PID controller can be stated as these equations. Controller 1 and controller 2 are integer order approximate transfer functions of the operators, fractional operators. In practice, the fractional integral operators frequently implemented as or 1 minus lambda, and a design method considering preservation of the optimality based on Bode's integral transfer function In this study, for tuning or design algorithm for controllers, I prefer an inverse controller technique based on Bode's ideal transfer function in frequency domain, and then an objective function was obtained to match the frequency responses around the crossover frequency. Then it then demonstrates how the integer order equivalent can be incorporated into the controller design process by replacing approximation controller function with ideal FOPIT controller function. The reference model, Bode's ideal transfer function. The closed loop transfer function of the unity feedback system for Bode's ideal loop is given with this equation, where omega c denotes a gain crossover frequency, and gamma is fractional order open loop transfer, fractional order of open loop transfer functions of Bode's ideal transfer function. And we can write the closed unity feedback Bode's ideal loop by using these open loop transfer functions. The magnitude and the constant phase of Bode's ideal loop are obtained with these equations. Changing the DC gain does not affect the phase margin, because you can see from this equation the phase response only depends on a fractional order gamma, and the fact that the phase margin is independent of DC gain, and this provides the robust phase margin for variation of DC gain. This property is well known as isodamping in control theory, and Bode's ideal loop has been widely used as a reference model to set robust control parameters. Inverse controller design, the other name of this technique is direct synthesis. You can see a closed loop control system from this figure, and this is the transfer functions of the closed loop control system. You can use the Bode's ideal loop as a reference input or a reference system in design, and I can state GS is a plant and CS is a controller, and from this equation you can write this equation in an open loop, and after do this manipulation, you can obtain the inverse controller by using the ideal Bode's ideal transfer functions and the inverse of the plant transfer functions. after do this, you can write these equations in the frequency domain for inverse controller design. Then we have a minimization problem in the frequency domain. It can be established as these equations. In these equations, theta and beta are phase values for the controller, and ln C of G omega and the inverse controllers equations are magnitude of the minimization problem. When continuous fraction expansion based approximate for bit controller is replaced by ideal controller in this equation, considering the amplitude and the phase of the approximate controller, the controller design can be achieved by incorporating the approximation method in the design process. When the approximate transfer functions of the fractional order operators are written in place of the these controllers, and approximate controller is expressed with these equations. Optimization settings in this study, a genetic algorithm was used in MATLAB for 100 sample points in frequency range. This frequency range around the gain crossover frequency, and the determination of the lower and upper limits was conducted according to the test performance. Initially, lower and upper limits of coefficients, the fraction order PID controllers were taken as these values, and if it's necessary, the range can be narrowed. Then let's talk about simulation results. The proposed approach was first performance for ideal fraction order PID controller. And afterward, the same design was performed using the approximate fraction order PID controller in the design process. The proposal of designing the ideal fraction order PID first is to illustrate the optimal design performance of an ideal for-bit controller function may not be preserved when applying an approximation method. For simulations, our planned transfer function is g of s. This transfer function was used in the control system. Firstly, the ideal for-bit controller was obtained with applying the suggested tuning algorithm. For gain crossover frequency is 1 and fraction order is 1. For Bode's ideal transfer function, and sorry. And we can obtain the ideal controller as you can see in this equation. Then this ideal controller can be applied with an approximation method, and the approximate realization of this transfer function can be obtained as this equation. And you can see below of this equation the approximate transfer functions of the fractional order operators, controller 1 and controller 2. And this figure shows the frequency response, magnitude and phase response for desired phase margin. And you can see from this figure that design criteria were meet in the amplitude and phase responses for ideal fractional order PID, blue lines in the figure, and the phase response flattens around the crossover frequency, but you can see this from this figure. The design criteria is differ from the ideal one, and we can say that the design phase margin may differ when we use an approximation method in the implementation. Then we design the controller was obtained with suggested approach, and this fractional order controller design implemented as this approximation controller, and this figure compares the frequency responses of the designed and the approximate fractional order PID controllers. You can see that incorporating the approximation method into the design procedure preserves the design optimality in practice. This figure shows the frequency response in the variation of DC gains. The DC gains values change with the range 20%, but you can see the robustness of the phase margin from the figure. And the other figure illustrates the step responses of the approximate fractional order PID for changing of DC gains. The simulation demonstrates effects of the phase robustness for variation in DC gains. You can see the overshoots in the time responses are very close to each other because of the phase flatness at the crossover frequency, according to ideal Bodès loop. And let us look at another example for another design specifications. Fuzz margin, and we used same plant transfer function in the simulations, and the desired fuzz margin was obtained for crossover frequency is 1, and the fraction order gamma is 1.33, and the ideal fraction order PID was obtained. This you can see from this equation, and implementation of and implemented of this ideal fraction order PID, and you can see again this figure. The specifications are not met when use an approximation method for implementation. The fuzz margin of approximate fraction order PID cannot satisfy the frequency design specifications in the frequency domain, and then we used the proposed approach for design the controller, and the approximate fraction order PID was obtained for the desired fuzz margin, and it can be implemented as implemented with this approximate controller, and you can see from this figure the frequency response of the designed fraction order PID and its approximates match, good match, and figure shows that desired fuzz margin can be preserved during implementation, and you can see from this figure the frequency response for the approximate controller for the gain variations, and I can state the gain change, but the fuzz flatness around the crossover frequency was preserved. And the other figure shows the step responses of the closed loop of the system, open loop transfer functions, and we can state that the gain changes, but the overshoots of the step response are similar, and the desired specifications can be preserved in implementation. And conclusion, this study demonstrates that a fraction order PID controller, which is designed as an ideal form for frequency domain specifications, and you can face with an inability to preserve its optimality in the real world implementations, since it's necessary to use approximation methods in implementations. It has been discussed that including incorporating the use of approximation method in the controller design process can overcome this problem. To this end, design approach presented in a former study was employed to discuss the preservation of design optimality by including the continuous fraction expansion method in controller design process. And the simulation results show that the method could contribute to the preservation of design optimality in real world fraction order PID controller implementations. Thank you for listening. Sorry, I'm very excited. Okay.
Thank you for presentation.
Questions?
No question. The next presentation, dear Sami Arslan.
Yes, sir. Could you hear me?
Yeah.
Excellent. Let me share my screen first of all.
Pardon.
Could you see my screen just
Yeah.
now?
Yeah,
Okay.
you can start.
Okay. Let me start. Thank you so much. Thank you so much. My greetings to all participants and organizers of the conference. I will try to use my time efficiently. Before starting my presentation, I would like to briefly introduce myself. This is Sami Arslan, General Manager of Pro Method Engineering, and he is currently pursuing PhD degree at Gazi University under the supervision of Dr. Iskender and Dr. Navruz. Today, I am encouraged to present our excellent work, maybe different work, called Optimal Design of an In-Runner Direct Drive Synchronous Permanent Magnet Starter Generator, especially for UAVs. I will start with an introduction after talking about the motivation of our work and the design system design requirements. I will examine the FEM design studies and finally discuss the results obtained as well. To begin with, focus of the work. This paper explores the optimum design of a low voltage, in-runner, direct drive, and high-speed synchronous permanent magnet starter generator, especially for small surveillance UAVs equipped with a 3W55 piston engine. As is well known, the propulsion system of UAVs is composed of fuel, hybrid, or electric engines. Figure 1 summarizes the propulsion system architecture. Piston engines are internal combustion engines that convert heat energy into motion energy as well. These engines have a higher usage area than the turbine engines due to their advantages, such as high cycle efficiency, shorter startup duration, less maintenance, and higher unit volume power density. Except that the increasing market volume of the hybrid technologies accelerates the studies in this field and makes them favorable. However, the development of permanent magnets and control engineering has ensured that starter generator structures are a key function in increasing power density in hybrid UAV systems mostly. Starter generator is a high-speed and highly efficient spatial rotary electrical machine in which the same machine can be used as a motor and a generator. It provides the first drive mechanism required for the UAV piston engine to start up in motor mode and charging the battery group of the electronic system after the piston engine starts in generator mode. They are mostly connected to the system as direct drive or belt drive. By integrating direct drive starter generator structures into UAVs, advantages such as removing powertrains, regenerative braking, reduced startup heat, and removing JATO and CATO systems are achieved. Studies for starter generator in literature are most divided into two groups. First one, in-runner and the outrunner topologies, depending on the rotor position. Actually, the outrunner topologies, as in figure 5, may cause some disadvantages in practice, such as difficulty in balancing and cooling, low efficiency, low mechanical stability, and low IP protection level. Within the more electric aircraft discipline, novel in-runner starter generator structure is proposed with the motivation to overcome these disadvantages and to achieve additional features such as higher propulsion system efficiency, wide range of operating speed, faster dynamic response, and field weakening capability. The proposed model consists of stator, rotor, permanent magnets, retaining sleeve, and the conductors. If we investigate the design specifications more, the operational zones of MOS are defined as in figure 8 by UAV manufacturer. When the graph is analyzed, starter generator acts as a starter from 0 to maximum torque zone, as a motor between maximum torque and maximum power zone, and as a generator between the maximum power and maximum speed zone. On the other hand, required torque, output power, and rated speed is 1 kilowatt and 4,500 RPM for motor mode. Besides, 1.25 kilowatt and 5,500 RPM for generator mode, except that limitations such as outer diameter, mounting hole diameter of flange, length of model, and total weight of UAV require the system-based design to reach maximum torque density, although there are some market products. The electromagnetic design starts with analytical calculations. Initial dimensions are input to ANSYS RMX for sensitivity analysis, which is a template-based tool for the fast analytical evaluation of electrical machines. The analytical structure is then tuned in Maxwell 2D and Maxwell 3D, which are high-performance interactive numeric software packages to solve electromagnetics by solving nonlinearities and leakage fluxes. The ratio of stator slots and point numbers is a challenging issue, and the right choice increases the winding factor and reduces space harmonics. However, increasing the number of poles complicates the driver structure due to high frequency of voltages. When we see the figure 11, it is very interesting in that it examines some combinations of slot numbers and point numbers in terms of efficiency, frequency, the weight of active parts, copper loss, and the torque density. The variation of 36/8 is chosen in the light of frequency and experience. The preliminary dimensions are obtained using the PMSM design equations. The independent design variables are listed in table 1. On the other hand, based on the analytical calculations, the D square L product is obtained as 150 cubic centimeter, as can be seen in table 2. The square L segregation is based on considering the design constraints. The weight, as we review the figure, the weight decreases as the model length decreases, as shown in figure 12. However, a shorter length will cause production and winding problems. The stack length is chosen to be 50 millimeter, considering the size limitations specified in figure 9 previously, and the end span length of coils. The stator and rotor yoke thickness is determined so that the magnetic operating point is close to the saturation, which is 1.5 Tesla, to ensure minimum weight. It is confirmed that the model does not saturate at the maximum operating frequency, as closely seen in figure 13. Another interesting point is to decide thickness of permanent magnets, which directly affects air gap flux density, which is accepted at the beginning of the design. It is optimally obtained at 3 millimeter magnet thickness, as shown in figure 14. Higher magnet thickness will cause the materials to become saturated, while lower magnet thickness will result in lower magnetic loading. You can see the you can see the Carter effect due to the slot openings in decreasing portion of the curve. However, the effect of permanent magnet temperature changes on the dynamic torque, which is 2 Newton meter, is shown in figure 15. The required torque is obtained with the torque ripple of 0.11 Newton meter for worst case conditions, which is tolerable for starter generators as well. However, further skewing techniques can be applied to the stator or permanent magnets to reduce the ripples. In the generator mode, the battery pack is charged, as we mentioned previously. Therefore, winding data such as turn numbers and schemes are arranged based on the minimum operating speed. Figure 16 compares the induced phase voltages for the operating speed range in generator mode, which actually satisfies the requirements. Figure 17 shows the motor and generator mode efficiency. The required design is met with efficiency of 90% for motor mode and efficiency of 91.5% for generator mode. These are rated values. Finally, we can discuss the results obtained. This is my last slide, and I am finishing up. Table 3 compares the design methodologies. The output power is 1 kilowatt in motor mode, and 1.25 kilowatt in generator mode is provided for S8 duty cycle. The analytical design model efficiency, which is 84%, is increased to 87% by tuning with RM expert sensitivity analysis, and increased to 90% by Maxwell 2D optometrics. The results show that the accuracy and talent of numerical softwares, the numerical simulations discussed indicate the potential usage of the novel starter generator for hybrid UAVs. Subsequent efforts will be devoted to producing and testing the proposed structure. Thank you for your time. This is end of my presentation. I hope it is helpful. Now I am willing to answer your questions as well.
Thank you for presentation.
You are welcome.
The next presentation, dear Mohammed.
Yes, doctor, I am here.
Okay, you can start.
Yes, doctor. If my voice and the screen is clear, I can continue.
You can start.
Yes, doctor.
Please.
Intelligent generation system automation using IoT technology. It is a review with the ID 277. Presented by Mohammed Sulaiman Mustafa Al-Kitab University, Iraq, supplied by Dr. Hakan Kutucu, Karabuk University. Before I start, this is a review paper, so we focus on the article that in the 5 last years. First, we introduction and go with the problems and the common view of these articles, and then individual viewpoint of these articles and the conclusion. In the introduction, irrigation means the planting, good planting. The importance of the good planting is protect human from the bad weather changes. What I mean here is change some places as like lack of rains, droughts. They continue going to the bad. And some places is flooding with the rains and also another weathers. This is going to be worse and worse if we see the last 10 years because of the global warming. Then we have also the importance of planting the oxygen, planting more oxygen. Sometimes they say 1 person must be equal to the 10 trees Also covers from the direct sunlight, shadows, and the heavy rains. If in our city, they do a study in the same city, only 1 kilometer away from the city, we have no tree coverage, and the place, another place will have a tree coverage, is the difference is going to 5 degrees of Celsius. It is very changed. Protect from global food shortage, as we see the wheat problems in the conflict in the war, because we have a lot of empty lands. We don't use it as making planting for foods, like especially the wheat. Here we have facing our problems. If we have specials of farming or planting or not, the time and the effort consumption. If an irregular person want to participate in against the global warming to do planting, they take from him the time and effort. We know of the modern life, we have some obligations. So not our time is complete free for this matter. Also accuracy. If we decided to care of a plant, our accuracy for giving the water or something is not accuracy, because we will just observation of and looking to the status of soil and the tree and give him the water like that. This makes change from day to the another day. This small change leads the large result in the bad way. So the accuracy is a problem if you use the old techniques, because we have old techniques still using, just looking and seeing is the problem or not, not using the new techniques. Human problems, observation, forgetfulness, and the tedious, the bored. Because new modern life make human to sit a lot on front of PC or mobile or TV, make him don't want to go and walk to see the plants or what he caring about of irrigation, to give him water or some caring, because sometimes he forgets, sometimes he bored to do, because the moral obligation, if you decided to do this in first week, you have a moral obligation, not same as 1 month, because it always know our obligations will go few and few. Okay. For common overview of the articles, we can imagine or describe the articles like that. We have plants and farms, maybe every plant, maybe sector of plants or farms. We have some sensors and controllers, and this parts connection to the other interface, like controlling of them or reading data from that sensor. Then they connected to the IoT interface. This IoT interface connected to the IoT platform. Maybe in some articles or some proposed articles, maybe all to this IoT interface and sensor control interface in same device, maybe not just IoT interface or just in interface of controller. They change from article to article, but in general view, we can separate these parts. In the common sensor that almost used in every articles, the soil moisture YL69, as we see in the left side, the part, electronic part, have 2 parts, one part going inside the soil and the other parts, they have pins, ground and VCC. The important pins is the A0, the A0 and D0. The A0 is output between 0 and 1024. The input is between 2 numbers. The range, depending on the device, we can do this reads is inverse. They don't read the moisture, they read the dirt of the soil. So we need to take it one is complement, then convert it to ratio between 0 to 100 because of the studies is to make this studies clear to the readers. They change it to the some numbers to can measurement and do studies. So the end of this read they convert to 0 to 100%. We talking about this part. In the second part, the controller, as a lot of people know, the relay SRD 5 volt DC SLC. This part is making major role in the planting or farming because they controlling in a lot of device, whatever is their volt, whatever is needs. So they can separate our interface, control interface from device. One is the example is water motor for aggregation. So the idea is when coming a signal to this relay, they making 4, 6 to 5 is connection, or in the normal close, they 4 to 5 in the normal where are no signals. Where are signals, the 6 to the 5 they connect. I mean here. So we see a lot of use this device in articles. As a sensor interface, we have some demands and needs for this parts. They must be robust for electric sensor. They take various of electronic sensor. They take a lot of from sensor and the various type and match. This is the most problem of if don't allow to connect with it. Also, major sensor library supported. If you don't have your library to connect the sensor, you have some problems. Also, big community. We have some big community, cheap, not expensive, so you can put a lot of this device, easy to use. The important things, many pins, the analog in, because if you using the soil moisture, you need a lot of analog in. So this is very important. But this device, like if we take example Arduino, special Arduino Mega, because a lot of pins, they have a lack of using a network and internet. So you want to put shields, but shields taking a lot of pins, almost half of pins. So we have some problems of connecting to the other side, the IoT. If we focus to the IoT interface, they have a robust for internet connection, IoT online platform supported, big community also, but as less pins, especially analog in. We have example of ESP or Node MCU, also Raspberry Pi, also have not much like example analog in as Arduino Mega. We have talking in this part. The articles connecting to IoT platform, they have, depending on the IoT protocol using some protocol MQTT or HTTP request. So what he used in this article, they change from depending on the protocol, if it's supported or not. Second part, some articles doing from scratch, a platform from scratch, from zero, or using already have in the internet. We have some also problems with if you're using free versus premium, like if you see the type of the IoT platform. Also selecting this one of this IoT platform, depending on the final porting, some farmer want to only use that mobile, don't use like example a PC. Maybe no, it's the team of maybe 10. So they want to use a web application all together parallel controlling. So what is the porting? What is the final porting? This is make change if this IoT platform is useful or not. Okay. If you see in visual viewpoints, taking the last 5 years, like Zamura, as we see in the right side, the core of the system suggests using the local and the edge and the cloud base. What does mean local? Local is inside the tree, very near. Edge means we have some control point, maybe far, maybe it's common between farmers, but it don't need the internet. That means the edge. And the cloud-based approach must be, we have internet to connect to cloud and approach. Swapping between these techniques, because wherever the proceeding is the nearest to the tree, they be fast, no delays, cheap. When they be far from trees like edge or cloud, they need some demands like internet for cloud base, but also you can do complex procedure or modern techniques with the cloud using. In the Al-Zubairi article, using Internet of Multimedia, IOMT, they're using camera to get the live view of the tree or the plant, seeing its leaves, and the image processing using MATLAB on incoming image from the planet. This is his approach. Maybe it is a unique approach to see the planet itself without using sensor, or maybe using sensor, but depending on the camera itself, going to yellow or some bugs eating these leaves. The Quadrupy focus on the farming is distance is a lot between this farming. They have a problem distance coverage. So they propose using long range wide area network, LoRa-1, as you see in the figure. The sectors of the planet or the farms, it is very very far from our control point. And also the places don't have internet coverage. So we have some problem to control these farms from far distance. So he decided, or he proposed, using LoRa to control and get data from these sectors. He focusing in that part exactly. The GAIWAB article is saying we must be complex this techniques, because we have a farmer maybe don't have that education. So they propose simplicity and classic, using a phone with connected to the IoT platform, the FOEMS one, and watching soil moisture versus the air humidity and temperature, and doing procedures using the difference between them. If they feel the air is more humidity going to drop, so the soil moisture will be going to drop, doing a study to this practical sensors. In the Al-Maliki architecture, the environment parameter monitoring utilized using aerial IoT drones. They controlling these drones from control point and watching the tree, also caring of the tree if have some problem or not. But we have some problem here, the complexity and the maintenance. If some have a problem in the drones, they need special caring. So if in the general, as I see that they may be not successful in the general farmers, maybe in the special farmers, maybe very have difficult trains to going by walk or going the normal cars, maybe don't you use fly IoT drones. So he focusing on this part of article. In the last and the run article, they're using wireless sensor network. Means wireless sensor network is like sensors and connecting like each network and the broadcasting data from sensor to sensor to sensor until going to control point. If you see the figures, you will understand. So this wireless sensor network, as all know, it is very cheap, not that expensive. So make you a lot of coverage. Also teaching data from this farm or controlling on it. And supposed to extend coverage if very far using UAV connecting unmanned aerial vehicle, also some kind of drones, connecting with wireless sensor network to make this coverage is more. The conclusion, we have some conclusion is very important. First conclusion is the static tree lives make less solution because the tree not developing by itself. What does mean that we have a car or have a PC or mobile to do development and this device is developed and developed? No, it is the static tree of life. Same tree will be live as same tree as 100 years ago. So the tree is have a static life. So we can't do a lot of development. We want to optimize how to care of it. The second point is when I discussed with the farmers, the distance between city to the farms and lack of energy and internet. As we see, some farmers very far from cities, maybe also some phone don't work there. They're using walkie-talkies. So when have no good energy, I mean not just sun energies, the energy from electric and sun needs to work some devices. And also internet is very problem. Don't have coverage in that area, especially in the Iraq country. So this make a very problems. So depending on the edge computing more than IoT based cloud computing. The last one is the lack of education of farmer, because there are a lot of research and less applicable because there are gap between researcher and the local farmer. The local farmer, they don't have this education to go and read studies about what is the last research. So we have some gap between researchers and the farmers. This can solve by only a farming company some engineers go to see what's the last research and come with the device, with applicable device to propose to the farmers with this idea. If one farmer used, the other farmer will see and use it again. This lead is the good irrigation and good planting. Thank you for listening.
Thank you for presentation.
Thank you very much.
All presentation completed. See you next session.
Okay, thank you very much.